Hi all, welcome to the new episode of Tech Insert. Today we are going to assemble and package a universal timer using a 555 IC. This is the circuit diagram of the universal timer. Here you can give negative trigger or positive trigger. Since 555 is a negative trigger input IC, we are actually converting the positive trigger to negative using a NPN transistor BC547. These are the components used for initial testing. Later we will use more components like relays, transistors, etc. along with this. Okay, let's make it. Always use IC base or IC socket when you are assembling with ICs. 555 as a timer is basically a monostable multivibrator. Monostable multivibrator means one state is stable. Here output low is stable state. When we apply a negative trigger at the trigger pin of the IC, then output will goes to high state and it will stay as high for a predefined time period and will return to the low state and will continue in that state until next trigger. We can even calculate the time period of how many seconds timer need to be in that excited state. Please go back to the circuit and look once again. Then you can see we have marked a resistor as R and a capacitor as C in red color, which will determine the on time period in seconds. The formula is 1.1 R into C seconds, where R in ohms and C in farads. We have provided a preset which can be used for adjusting the on time period. In our circuit, the maximum and minimum on period time we can set is 56.87 second and 5.17 second respectively. In our circuit, instead of 470 MFT capacitor, if we are using 4700 MFT capacitor, then the maximum on period will become nearly 9.5 minutes. Like that, by changing the resistor and the capacitor, we can even stay on for hours. When you are getting a circuit, assemble it similar to what I am doing here. When working fine, then we can deassemble the circuit and assemble it inside the PCB or a common board. The advantage is we can make sure the circuit is working fine or not. Monostable multivibrators can be used in burglar alarms, trigger alarms, motion sensors, etc. Okay, it's testing time. You can see when I give the trigger using the micro switch, the LED will light up and goes to the off state after some time. We can adjust the time period using the preset. Now you can see the time period increased. I have changed the time period to low. What I am doing is I am continuously giving negative input to the trigger pin of the IC and you can see it has no effect in the output. So 555 is actually expecting a trigger input, not continuous input. Now we will connect a relay at the output and test it. Output of 555 IC is not enough to drive a relay continuously. So we should use a switching transistor for that. If you haven't subscribed to our channel yet, please click subscribe button. Press the bell icon so that you will get the notification whenever we upload a new video. The 9-volt battery with me has low voltage, so I am giving a 12-volt power supply to the circuit and listen the tick tick sound of the relay. Listen carefully. I will move the relay close to the mic. The microswitch is connected to the negative terminal and thus negative trigger. What will happen if you need to utilize a positive trigger? Since your circuit is universal, then it should accept positive trigger too. For that, we will use an NPN transistor for reversing. For that purpose, we are using a BC547 transistor here. We have created a video of a stable multivibrator, and the link we have given it in description and also information box, which is right side top of this video. Now we will assemble everything inside this common board. I will quickly assemble it and will come back. We will pack everything inside this small box. If you have any idea of packaging this circuit, please comment your idea under this video. We will put holes in it so that the pins can be put outside. We have put the hole in the box and we will be using this male PCB connectors and will glue it in the hole and will connect using wires. If you haven't subscribed to our channel yet, please click subscribe button. Press the bell icon so that you will get the notification whenever we upload a new video. The right side 3 pins are the relay output connections. We have connected 3 pins for negative and 2 pins for positive so that the same power supply can be used for powering some other device. And also yellow and green, which is negative trigger and positive trigger. The pin details we will write in this piece of paper, else we will forget the pin details after some time. These three are negative and next two is positive, and the next pin is negative trigger minus T. We are marking it. Next is positive trigger plus T. That is relay's common connection and normally closed connection and normally open connection. In order to avoid scratches in this paper, we are using a cello tape for making it safe. Now we have to test it. For that we are actually using this kind of female connectors for it. We will do a simple test on it and then we will connect a 230 volt load to the relay and we'll test it. If you haven't subscribed to our channel yet, please click subscribe button. Press the bell icon so that you will get the notification whenever we upload a new video. How can we test the relay terminals? Okay, we can do a continuity testing on it. For that we can make use of multimeter in continuity mode. Okay, now we will test using a 230 volt load. Don't worry about these relay pins. The relay pins are totally isolated from the other pins, so there will not be any shock hazard from other pins. I made a mistake. Instead of preset, I should have used a linear potentiometer and connect it outside. Then we can control the time period from outside. Okay, I will do that later. Now we will test our timer by triggering from an infrared sensor module. This is a 5 volt regulator IC for infrared sensor module. We are using TSOP1738 module and 7805 for 5 volt regulation. We have connected all wires between sensor and timer. The sensor module output will be normally in high state and will be in low state when infrared light falls on it. The light is on because when power is on, the sensor output will be low and immediately go to high state. The initial low state is actually triggering the timer. We don't need to worry about it. You can see the infrared light of the remote control. Try this at your home. If you like our video, please click like button. If you do not like our video, click dislike button. If you have any suggestions, please comment on this video so that we will know that. If you haven't subscribed to our channel yet, please click subscribe button. Press the bell icon so that you will get the notification whenever we upload a new video. This is KR with the GR and M signing off. See you in another video. Till then, goodbye and please take care.